Today we're going to talk about geometric sequences. So, a geometric sequence is a sequence in which each term can be obtained from the previous one by multiplying by the same non-zero number. We call this number the common ratio, and we denote it as R. Okay, so in order to tell if a sequence is geometric or not, you have to identify the common ratio. The common ratio can be found by taking u sub n plus 1, which is going to be your next term, and dividing it by what your previous or your current term is. So all you have to do is do next divided by previous, and you should be able to get your common ratio, and it should be the same no matter what two consecutive numbers you are talking about. So let's get into the general term formula. It says, for a geometric sequence with the first term, u1, and the common ratio r, the general term, or the nth term, can be found by using the formula u sub n is equal to u sub 1 times r to the power of n minus 1. So let's look up some examples. Number 1, it says, consider the sequence, negative 36, 18, negative 9, and then 9 over 2. And it's going to continue. The first thing that they want us to do is they want us to show that the sequence is geometric. So, in order to show that a sequence is geometric, we look for a common ratio. So remember, your R is equal to your next term, u sub n plus 1, divided by your term that you have currently or previously, which is u sub n. So if we do that, all we have to do is take two numbers at a time. So we can say 18 divided by negative 36. 18 divided by negative 36 is negative 1/2. Then we can do negative 9 divided by 18, which is also negative 1/2. And then we can do 9 over 2 divided by negative 9, which is the same thing as having 9 over 2 times negative 1 over 9, which simplifies to negative 9 over 18, and negative 9 over 18 simplifies to negative 1/2 still. So I divided my two consecutive numbers, and I see that I have all of them simplified to negative 1/2, which means that my common ratio, or my R, is equal to negative 1/2. So now that we have that, we can now find the general term, or u sub n. Well, remember, the general term is stating that u sub n is equal to u sub 1 times r to the power of n minus 1. So we just substitute in what we know. So if that is the case, we will have u sub n is equal to u1, which is the first term, which is negative 36. And then we want to multiply by our common ratio, which is negative 1/2. And it's going to be raised to the power of n minus 1. So that is our general term, or our general formula. Okay. So part C says, hence, find the 10th term as a fraction. So if we want to find the 10th term as a fraction, we're going to have to substitute in. So we want to find u sub 10, which is going to be equal to negative 36 times negative 1/2 to the power of 10 minus 1, because we're subtracting from our exponent that we plugged in and we substituted in 10 there. So I know that this is equal to me having negative 36 times negative 1/2 to the power of 9. So I'm going to enter that into the calculator. Negative 36 times negative alpha y equals 1/2. Close the parentheses and put to the power of 9. And we end up getting that we have 9/128. So that is my answer. All right. Example number 2. It says, find k given that k plus 1, 4k, and 3k plus 5 are consecutive terms of a geometric sequence. So remember, if you take your next term divided by the previous term, you should get your same common ratio every time. So I'm going to make an equation with that. So I can say that 4k divided by k plus 1 is going to be equal to 3k plus 5 divided by 4k. So what I'm going to do here is I'm going to cross multiply. And when I cross multiply, I'm going to have 16k squared is equal to 3k plus 5 times k plus 1. And if you want to, you can distribute and multiply it all out and combine like terms on the right-hand side. But it is not necessary because we are going to solve this using the graphing calculator. Now, if you wanted to solve it by hand, then what you would have to do is you would have to distribute and combine like terms on the right-hand side and then set that resulting equation equal to 0 and then solve it by either factoring, completing the square, or the quadratic formula, whichever one you would want to use. But I'm going to use the graphing calculator. So remember, anytime you solve an equation using the graphing calculator, you type in the left side into y1, and then you're going to type in the right side into y2. So I'm going to type in 16x squared. We don't put a k there. We use x in the calculator. And then we're going to have 3x plus 5 in parentheses times x plus 1. Once we do that, we can press graph. And we need to see where the two graphs cross. So I see that those two graphs do cross, but I want to make sure that I can see it in the screen. So now that we can see it on the graph, we can tell in the top right-hand side of the curves, when it gets a little bit to the top near the y-axis, we can tell that the graphs are going to cross there somewhere in that area, but we can't see for sure. So I wouldn't necessarily want to zoom out, because if you zoom out, it's going to make your graph appear very small. So we're going to just change the window settings. So when you press window, you can scroll down to the Y max, and you can change the largest Y value that you can see on the screen. Let's change it to 20 and then graph it. So now that we have it graphed, we can actually see where it crosses, where the two graphs cross each other. So they intersect twice. So in order to find those intersections, we press second trace, go to number 5. Then we need to scroll until we almost touch each intersection. So we're going to scroll to the one on the left and press enter 3 times. So as you can see here, remember, we put an X in the calculator in place of K. So we are going to look and we see that K is equal to negative 0.385 in three significant figures. And we also see that K can be equal to our other intersection, and we will find that by pressing second trace, number 5, and scrolling until we get close to that one, and then pressing enter 3 times. So we see that here K is equal to 1. So those are the values of K, so that way we will have the geometric sequence. Now, sometimes you may be able to write your decimals as fractions if you want a more accurate number, and you may need to solve the equation by factoring if you want a more accurate number. If you were to solve this by factoring, you would have gotten the fraction negative 5 over 13 if you were to solve it by factoring. And if you were to do negative 5 divided by 13, as you can see, you would have gotten approximately the same number that we got when we found the intersection. So I just wanted to let you all know that negative 5 over 13 was how we got that answer. If we were to solve it by factoring, you would have gotten the exact fraction. But instead, since we use the graphing calculator, we put the number or the answer in three significant figures. So I just wanted to bring your attention to that. All right. So now let's look at number 3. It says a geometric sequence has u sub 3 is equal to 18 and u sub 6 is equal to negative 486. We want to find the general term or the general function. So in order to do that, we need to use the information that we have. So when we use the information, we see that the third term in the sequence should be 18. And the sixth term in the sequence is going to be a negative 486. So what we can do here is we can say, okay, in order to get these numbers, in order to get u sub 3, you had to start off with u1. So we can say u sub 3 is equal to your first term, u1, times your common ratio, and you multiply by that common ratio 2 times before you ended up at the third term. So what I mean is you started off with the first term, then you want to get to the second, then you want to get to the third one. Okay? So I'm saying here that the third term is 18, which means that you had to start off with the first term, u1, and you're going to multiply by r twice in order to get 18. Okay? So, and instead of using u sub 3, we're going to actually write u sub 3 as 18 here, because that's what u sub 3 is. The third term is 18. So now we're going to use the second equation, which is u sub 6, which is negative 486. And we found that by taking the initial value or the first term, and we are going to multiply the common ratio 5 times in order to get to the 6th number. So one thing, remember, that you should know is if you divide your terms, you should get your common ratio. So let's do it. So if I write myself an equation and I say negative 486 divided by 18 should be equal to u sub 1 times r to the power of 5 divided by u sub 1 r to the power of 2. So I'm setting me dividing each side, I'm setting them equal to each other. So if I use my calculator, if I do 486 divided by 18, I get negative 27, which is equal to, then we have u sub 1 divided by u sub 1. That will cancel. And we know that r to the power of 5 divided by r to the power of 2 leaves us with r to the power of 3. Now, in order to get r by itself, we have to take the cubed root of both sides. So when I take the cube root, my cube is going to cancel on the right. And then if I press math and go down to number 4, I can pull up the cubed root and then put negative 27 on the inside of it. And I end up getting that r is equal to a negative 3. So now that I know that r is negative 3, I can substitute negative 3 back in for r in either one of the equations in the beginning. I'm going to use the first one because the numbers are smaller. So here I will have 18 is equal to u sub 1 times negative 3 instead of r to the power of 2. So we know that negative 3 squared is equal to 9. So that is going to be the same thing as having 9 times u sub 1. And if you divide both sides by 9, you will end up getting that u sub 1 is equal to 2. So because we want to find our general term, I remember our general term is the formula. So our formula is going to be u sub n is equal to 2, which is u sub 1, times negative 3 to the power of n minus 1. So that is my general term or my general formula. All right. Let's look at number 4. Number 4 states that we want to find the first term of the sequence 4 square root of 3, 12, and 12 square root of 3, in which the sequence is going to exceed 700. So in order to do this, we have to know the actual formula for the sequence. So remember, the first part to finding the formula or to knowing the formula is to take your next term and divide them by your previous terms. So remember, your common ratio is always equal to your next term divided by your previous term. So we're going to have 4 and we're going to have 4 square root of 3 divided by 4. And we know that that gives us square root of 3. If we were to take 12 square root of 3 and divide it by 12, we would still get the square root of 3. Okay, so our common ratio is the square root of 3. And our general formula here will be u sub n will be equal to 4, which is u1 or the first term, times the square root of 3 to the power of n minus 1. So we want to see, when does this value exceed 700? So what we want is, we want u sub n to be greater than 700. So what I'm looking for is, when is 4 square root of 3 to the power of n minus 1, when is that going to be greater than 700? So that's what I'm looking for. So what I am going to do is, I'm going to go to y equals, clear everything out that I had in there previously, and I'm going to type in 4 times the square root of 3 to the power of x minus 1, because we don't put n's, we only put x's in there. And then I'm going to, on the other side, I'm going to put 700 in my y2. So now I am going to look at the table. So I am going to press second graph to go to the table. And I am going to scroll down until I see the value of y1 be greater than the value of y2. So I can see here that u sub 11, which is the 11th term, which is 972, that is the first term that is greater than 700. So 972 is my answer. So now, last but not least, let's talk about growth and decay. So now that we have talked about geometric sequences, let's look at real world applications. In most situations, we are going to have an initial value, which is your value when time is equal to 0. So we're going to look at growth and decay. So anytime we have a situation that's dealing with growth or decay, we use the following sequence. U sub n is equal to u sub 0 times r to the power of n. U sub 0 is the initial amount. R is the growth multiplier. N is the number of time periods. And U sub n is the amount after n time periods. So let's look at this example. It says, an investment account is opened with $500. The money is projected to grow by 7% each year. How much money will be in the account after 15 months and after 2.5 years? So the first thing that you need to understand is that they said they want the money to grow by 7%, which means that we need to have 100% of what we started with plus an additional 7%, which means that we want our U sub n to be equal to $500 that we started with, our initial value, times our growth multiplier, which is 107%, or in decimal form, 1.07 to the power of n. So we also need to understand that they said that this is happening each year. So in order to figure out how many years is in 15 months, we can just take 15 and divide it by 12. And 15 divided by 12 will give you 1.25. So if we're trying to figure out how much money is in the account after 15 months or 1.25 years, we can substitute 1.25 in. So we're going to have 500 times 1.07 to the power of 1.25. And we're going to substitute that in the calculator. And we get that the amount of money that is in that account after 15 months is going to be approximately $554.13 because we're rounding to the nearest cent. And remember, when we round, we normally represent it with the little squiggly equals. So now for part 2, we want to figure out how much is in the account after 2.5 years. So I'm going to copy the same exact formula down, and I'm going to put 2.5 for 2.5 years. We do not have to convert that one because it is already in years. So we have u sub 2.5, which is equal to 500 times 1.07 to the power of 2.5, which we see is approximately $592.15. Okay. So that is our answer there. So the next one says, how long will it take for the account to grow to $10,000? So if I want the account to grow to $10,000, I am saying that I want my formula equal to 10,000. And of course, you know we can solve it by putting the left side into y1 and the right side into y2. So once we do that, we will have 500 times 1.07 to the power of x. And then we're going to have 10,000 here. So now I want to graph this, but I'm going to go ahead and change my window settings. So if we click on window, we already know that we want the total value of the account to be $10,000, which is my y-axis. So I'm gonna put my y-axis, I'm gonna put it up to 15,000. And then as you can see here, just from 1.25 years to 2.5 years, it only increased by 40 something dollars. So I'm going to increase my X maximum because that's talking about time or the years. And I'm going to increase this to about 50 just to see what it gives me. So once I graph it, we're going to see where the two graphs cross, and then we can find the intersection. So now that I see this intersection, I can press second trace, and then I can scroll until I get the intersection. So I want to get to the intersection before I press enter 3 times. So I'm close to the intersection. So when I press enter 3 times, I see that it took approximately 44 years in order for it to reach $10,000. Keep in mind that when we are talking about time, we normally do not use decimals, which is why I said that it is 44 years instead of 44.2 or 44.3 years. All right. If you all have any questions, please let me know and I will assist you. Have a great day.